Math 3, Unit 2A, Practice 2A.1.2, adding and subtracting polynomials. Okay, so for these first 7, we are simply simplifying, okay, each expression. So what does that mean to simplify? Well, it means that we look at these and we say, okay, what can we combine? Okay, what is it that we can combine? So what we have to understand is what like terms are. Okay, so like terms have the same variable raised to the same power. Okay, so they're super samesies. Same variable raised to the same power. Okay, if they're not, you can't combine them. And all we're doing is simplifying them, so that's really what it comes down to. Now, even though these are in parentheses, there's nothing being multiplied to them, so they're good where they're at. The one exception is when you've got a minus here, because that a minus applies to every single piece afterwards. Okay, if it's plus, we like those because we just look for the samesies and combine. When it's minus, essentially what we have to do is turn each of these into the opposite version. So positives become negatives, and negatives becomes positives. So instead of 3x to the fourth plus 14x cubed plus 11x squared plus 2, it'd be more like plus negative 3x to the fourth minus 14x cubed minus 11x squared minus 2. Okay, and then we simply look for what has the same variable raised to the same power. Okay, so let's do these. And I would suggest trying to do these on your own first. But let's go. So first I look, what's my highest power? You always want to start with your highest power. You don't have to start with this first term. Okay, let's look and see what our highest power is. For this one, it happens to be the first one. So I've got negative x to the sixth. Are there any other x to the sixths? No, there are not. Okay, so because of that, I'll just write it negative x to the sixth. Then I like to cross it out. So now I look in my next one. What's my next highest? 10x cubed and 12x cubed. Okay, so these two we can combine. So I take their coefficients, because remember, 10x cubed is basically saying you've got 10 of these x cubes being added together. I should have picked a smaller number to do, huh? Okay, so there's 10 of them. That stood for that. Now, 12x cubed, there'd be 12 of them. So it's really like I've got all these x cubes hanging out. Okay. How many is that? 2 more. So when I combine them, because that coefficient 10, it's like we're saying there's 10 groups of x cubed being added together. 12x, we've got 12 of those x cubes being added together. So we're adding them all together, so how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. In other words, 10 plus 12. So we get 22 x cubed. Okay, then we look for the next one, 5x and a negative 8x. So 5 minus 8 would give us a negative 3 times x. Okay, then 6 and 7, we'd add those to get positive 13. So if that confused you, think of it as like, you know, I've got 5 positive x's. I've got 8 negative x's. Remember, the positive and the negative version of something undo each other. Is that 8? Yeah. So that undoes it. Those cancel, those cancel, those cancel, those cancel, leaving me with 3 negative ones still. Okay, that's why that works, in case you weren't sure. But there's my answer. Okay, that's as simple as I can get it right now. If I knew what x was, I could do it better. Some of you may think, well, why can't I just combine those x's together? It's because they're not the same thing. Okay? That negative x to the sixth, okay? X to the sixth, remember, is the shortcut for x times x times x times x 6 times, right? Because there's one of these guys, and then we've got x cubed, there's 22 of these guys. Okay? You think you can combine multiplying, but you can't because this stands for one term. That stands for one term. And obviously they're not going to be the same number, so that's why we can't combine them. Okay? That's why that can't become x to the ninth. Because that would be 9 of these guys, which we know if you put a number in there other than 1, they're not going to be equal to each other. So we can't make them 2x to the ninth. Okay? Doesn't work that way. Okay? That's why we can only combine like terms, things that are the same. Alright, let's bust some of these out now. So, number 2, look for my highest degree, 14y cubed. There's no other y cubes. That's where we start off. Okay, look up the next one. It's y squared. I've got a positive 8, positive 18. 8 plus 18 would give us positive 26y squared. Okay, then I've got a regular y to the first. Negative 8, positive 5, give me negative 8 plus 5 is negative 3y. Then my constant, negative 19, negative 14, two negatives together make a bigger negative, so that would be negative 33. And there's our answer for that one. Okay. Now we take a look at the next. So what's my highest degree? X to the fourth. Now this one's minus, so I would treat it like this. I think this is the easiest way. Let's change that to an addition, but then we have to change all of those to a negative. So in other words, I end up with 20x to the fourth plus x cubed plus 18 plus negative 3x to the fourth plus negative 14x squared plus negative 11x squared plus negative 2. I could have just put minuses. Okay, then 20x to the fourth, negative 3x to the fourth gives me a positive 17, not a negative. I almost wrote a negative. So 17x to the fourth. Okay, then I eliminate. Next up, I've got an x cubed and a negative 14x cubed. So positive 1 minus 14 would be a negative 13x cubed. Okay, cross those ones out. Now I don't have any other x squareds, so I just get negative 11x squared. Then I have positive 18, negative 2, so positive 16 for my constant. And there's my answer. Okay, so same idea. Okay, so make that a positive, negative 15, negative 13, positive 6, negative 10. So do we have any other x to the fifths? Nope. Okay, so I start out 11x to the fifth. Now x to the fourth, negative 4, negative 15. So negative 19x to the fourth. Cross those out. Okay, x cubes, no others, so just hope that's a negative, huh? Negative 13x cubed. Positive 19x, positive 6x, positive 25x. Then I end up with a negative 10 for my end. And there's my simplified. I know that doesn't look more simple, but it is, trust me. Okay. Now, number 5. Same idea. This one's plus, so that helps out, right? So my highest degree is a 4. So we start out, no other ones in my second term. Negative 10z to the fourth. Then we go, cubed. Is there any other cubes? Yep. So 2z cubed, 5z cubed would be a positive 7z cubed. Cross them out. Okay. Positive 14z squared, negative 17z squared. So that would be a negative 3z squared. If you need to use a calculator for these numbers, do it. No other z, so negative 13z. Positive 15, positive 8 would give us a positive 23. Okay, number 6, we've got a minus, so I change it to plus, which changes everything. So 2 become positives, 1 becomes negative. Okay, x to the 6th, that's my highest. Now I've got a positive 17x to the 6th and a negative 4x to the 6th. So positive 13x to the 6th. Cross those out. Any x to the 5ths? Nope. So negative 12x to the 5th, it just stays there. Then 3x to the 4th, positive 6x to the 4th, positive 10x to the 4th. And then no other regular constant, so plus 20. Okay. Alright, one more like this. Okay. So, looking at this, we've got plus, makes that negative 3, negative 7, negative 8, negative 10. So, what's my highest degree? 3h cubed, negative 3h cubed. It's my highest, none other, so I leave that one how it is. Then h squared, so 12h squared, 7h squared. So they're both negative 7, so 12 minus 7 will give us a positive 5h squared. Then just a regular h, negative 8, negative 9, negative 17h. Then negative 10 and negative 15 will give me a negative 25. Alrighty, so we got all those ones. Now these last three, they're dealing with perimeter of a rectangle. Okay, so we've got a rectangle, and you'll usually have the same sides. So the perimeter would be y plus x plus x. Okay, so now we're imagining that these are our lengths and our widths. So instead of x, it'd be x minus 5. Instead of y, it'd be x plus 10. But the same rule applies. I just take those. And there's two ways you could think through this one. Okay, first way would be to simply go x plus 10 plus x minus 5 plus x minus 5 plus x plus 10. Okay, then I look for the like terms, so 1x, 2x's, 3x's, 4x's. So 1 plus 1 plus 1 plus 1 would give me 4x. Then I'm left with negative 5 and negative 5, which would be negative 10. Plus 10 would be 0, plus another 10 would give us plus 10. And that would be my perimeter. Not my area, my perimeter. Okay, that's one way you could do it. The other way would be to go like this. To simply go, there's two of these, so 2 times x plus 10, plus there's two of these, so 2 times x minus 5. Then we distribute, we get 2x plus 20 plus 2x minus 10. 2 times 5 is 10. 20 minus 10 is 10. 2x plus 2x is 4x. Okay, same thing. I don't care which way you do it. I'll do each of them one more time. Okay, let's take a look at 9. So the length, we've got x squared plus 1 plus x squared plus 1, right? We do it twice. Plus 4x plus 4x. Look for like terms. X squared, combine them, 1 and 1, make 2x squared. Okay, 4x and 4x give us 8x. Then 1 and 1 give us 2. And there's our area. Perimeter. Okay, then that last one, we've got 2 lengths, so 2 times negative 8x plus 24, plus we've got 2 widths, so 2 times 2x plus 3. Distribute, 2 times negative 8, negative 16x, 2 times 24, 48, 2 times 2, 4x, 2 times 3, 6. X and x, negative 16 plus 4 would be negative 12x. Regular and regular, 48 plus 6 would give us 54. Okay, so there you guys go.